because you all are students, and there'll be a lot of jargons, industry jargons. I'll try as much as I can avoid, and I'll make it so that you can correlate with your curriculum, like data structure, and the language you learn, and your day-to-day habit of doing transactions. Okay, so there is a technology evolving called blockchain, so before I explain you blockchain, I would like to understand. I would like to explain how internet works. I think a lot of you do internet is, you just get the data, right? You are going to a website, and let's say that website is in USA. The data center, the server is in the USA, and you are in the India, and you are in Burdwan. You're typing. So what happens is once you type something on your browser first connects it to your ISP, called Internet Service Provider. Let's say you are using a Geo phone, right, where Reliance is acting as the Internet Service Provider, and maybe Reliance is contracted with BSNL, who is giving the main internet service, and then that Internet Service Provider is basically checking, let's say, facebook.com. So it's trying to get a domain name resolution and saying where is the server this server is located. So he might see, okay, it is located in USA, the server is. So what it does is basically, it tries to find which is nearest another ISP. So maybe the nearest another ISP in Dubai. He forwards that your request to Dubai, and Dubai then maybe forwards to Germany, who is contracted ISP, and they eventually reach to USA, and they get the response. This returns back the response in a similar way. So internet is basically a combination of ISPs. So the internet service provider, so it's decentralized. That means tomorrow anyone wants to be an internet service provider, they can be. No one can stop. They can put up their server, and but they need to again have a contracted or trusted peers. When I say trusted peers, they need to know whom they will forward the request. So they might again, India there is a setup, ISP service provider setup. So they might be, BSNL, Geo, Reliance, and whoever other ISPs are. So internet is basically a decentralized model where when you send an email, basically, what happens is you find where is the server, right? So or you access a Facebook, that's how you communicate. But this is about information. So information sharing has become very easy now. Now let's say you want to share $1 or 1 rupee with someone. You want to share in a similar way. Hey, I would like to just say send an email, the money will flow to him. Or let's say you want to share you have a car. You want to sell to someone. So when you sell a car to someone, what happens is basically you transfer your car registration details to someone else. So that's what happens in internet world. You cannot do that same thing in the internet, because there is something called double spending. So you might send one rupee to someone, and again you can keep on sending, right? You cannot do that. So that's called double spending problem. So that's why the sending money or sending assets is so difficult nowadays, because there is someone has to be a middleman. So when you go to send a money, basically what happens is you have to use a bank, you have to use a central authority who will ensure that you have the money, and whom you are sending, he gets it. So you need to have a middleman who establish the trust between these two parties. Same thing when you go to for a shopping for what is called a big bazaar, right? You slide your card. I say, hey, I want to pay 20. This is $100 for 100 rupees purchase. So what happens is that when you slide a card, the card might be a Visa or Mastercard, right? So that Visa or Mastercard might be the issuing. So they will, in the POS terminal, it first connects to Visa or Mastercard, and then they connect to bank, and then they see that you have the money, and then it gets to deposited to Big Bazaar's account. So all this middleman in a transaction increases the cost of the transactions. So that is what the biggest problem. So and So why it is a very big problem? People might say, hey, everything is good, right? That's okay. There is a middleman. But the thing is that there are a lot of problems are happening. First of all, transaction cost is very high. So when you go for a cashless economy, right? Let's say especially India, where small shop wants to use cashless, right? They need to pay. Like if you use a Paytm today, if you use Paytm, you have to pay a certain amount fees for the transaction to the Paytm. So eventually, if your volume of transaction, let's say you only do business of 100 rupees per day, and if you want to use a cashless, so you will see that your transaction cost is more than your earning cost, the amount you earn. So and similarly, let's say you want to, let's say I'm in USA, I want to just send $20 to my friend in India. I can't do that because there is always a minimum amount of money you need to send. Otherwise, you will not recover the transaction cost, because transaction cost itself is more than $20 to send some money. So this is why I try to explain why blockchain, because blockchain is the solution to all these problems. Because as we are becoming more automated world, where there will be less human interference, more all things will be automated. So blockchain brought a new kind of data structure. So I think everyone in this room understand what is the database is, right? What is the relational database is, SQL query is. So what happens in a database, right? So today's model is what? I'll give a very simple example. So which is I think let me tell you where am I focusing today, the interest. So blockchain has 3 use cases I am focusing. I think for this curriculum, let's focus on the university results or certificate issuance. So this is another huge use case in the whole, in India itself is going on, that people wants to issue the certificates or results in blockchain so that they can counter the fake certificates. So there are so many fake certificates today. How do you validate? So today, there is a central authority, but when you go to somewhere, you go to some job site company, they saw, so they need to use a third party to do the background check, all these things. Now, if this result is issued on the blockchain, let's say you applied, got a job in TCS, right? TCS can instantly validate whether your results is fake or not. How? Through blockchain, and I'll tell you how. So I'm focusing on primarily these 2 loyalty points and gift card and university result issuance. Third, leave it now. That's another topic of our interest. But let's go back now. I'll just. So why blockchain? The same thing what I just explained, right? To understand the need of the blockchain, so have anybody heard about the Bitcoin? I think it's a huge thing, right? Our finance minister is saying it's a illegal form. So what happened is, I'll give you a little history that in 2009, there is a financial crisis happened. I think it was all share market went down, banks got bankrupt. So what happened is that today when you keep the money to your bank, the money is not yours anymore, it's a bank's money. And banks say, I owe you this amount of money, right? So if bank gets bankrupted, your money is gone. So you are no longer in control. So that time, there's some person called Satoshi Nakamoto, gave an excellent idea of peer-to-peer money transfer. So that means it's like a cash. When you go to a cash, you give 10 rupees and you get the item. So that's a peer-to-peer money transfer. He said we can do the same thing using blockchain as a peer-to-peer money transfer without using a middleman or bank. So we don't have to worry about the bank gets bankrupted, because the whole process is so transparent, so that there is no bank, there is no middleman. It's basically, what does it mean? Bank is replaced by a software. So there is a bank still, which is a blockchain node, but that is an automated software which is basically, basically taking the place. So, by the way, if you guys feel bored, feel free to ask questions. I know that sometime it might go over on the head, but I'll try to come back to the point which will quickly, but some context is needed. So what I was saying is that, so today when we go for shopping, what I just said, that in a retail store like, Walmart, we typically use the tools like credit card issued by the bank to complete a transaction. Here, between the customer and the provider, we have a bank who mediates the transaction and takes money from takes money from the customer account and route the same money to the provider. And this process takes time as it goes through other clearing and compliance, like the bank. You have realized that. And now the question is, why do we need a mediator? So the same thing, we can't, why can't we directly send the money to their money, directly send their money or assets to the provider directly? And the answer is trust. This. Yeah, so the answer is trust, right? So we don't trust each other. That's the biggest thing, and that's true. We should not trust each other, and even we should not trust the banks. We should not trust the financial institutions, because there is a fraud possibility. The whole thing is getting automated. So another thing is that Bitcoin is not blockchain. That's a misconception in the whole world. So Bitcoin is the first one who showed how to use a blockchain. But blockchain is basically more than that. Even in the Indian finance ministry has said they are interested in blockchain. They will be using blockchain going forward. So there is a huge potential. So I'll go back to I'll skip that. I'll go back to the main target. What is a blockchain? Let's get into that. I think all of you. So have you guys understood, right? Anything that why do we need a blockchain? Any question?
Sir, you
were saying that banks are taking money for transactions, but we know it has been introduced UPI transactions in India, sir. So actually, why we are transferring money this time now by UPI, it is not charging any money.
So yeah, UPI is an excellent example of private blockchain. So what UPI does is that they have set up a similar model, where there is no bank, like a Paytm also. Paytm also a similar example like UPI, where you are doing. But the only problem is it's not open. Say tomorrow I wanted to be another member in the UPI, I cannot do that. UPI has made it like a monopoly, right? So think about internet, right? Internet is nobody's monopoly. Tomorrow you wanted to have a service provider of internet, you can open up your ISP and you be an internet service provider.
But sir, like that means if we have the governing companies like Google and all that, they are just targeting their main data line basis. Like if we go in US only, they are ensuring FiberNet. Sir, means there are many reported cases in which you can see that the FiberNet is providing services of Google, like their mail, their sign up and all that, like YouTube only. And similarly, the Bitmate is also there. But Bitmate video loads quite slower than the YouTube video loads. Even if the data stream that is going on is still the similar.
No, I didn't get the question. So how are you correlating that with blockchain?
No, sir, I am not saying that. You are saying that it is decentralized, sir. The thing
Right.
is that the major companies that are there, they are centralizing the thing now. They are taking it under their control by their power.
That is the reason we have to move away. I mean, that is the reason blockchain is saying that let's put everything decentralized. Nobody will own, like Facebook, right? So there is a social blockchain is happening. Now Facebook owns everyone's data. So they can charge anyone and they can do monopoly in social data. Now if the social data, so that's what I'll come here. So what is a blockchain, right? So blockchain is a distributed database. So you have a database, so let's say UPI, right? When you do a UPI transactions, there is a centralized server where the data is stored, right? So if that centralized server is hacked, if someone is hacking that server, UPI server, then it's vulnerable, right? Everybody can do anything. So you are vulnerable because one server can be hacked, right?
Sir, one more thing, sir. Sir, if you are saying like that, then Bitcoin is somewhat using blockchain. I know, I don't know about that. You are saying that it's somewhat using its model, but you may be knowing that in November or October, I don't know exact date, the e-cash, a nice hash account was stolen.
So there are two things. So one is server. So whatever is hacking is happening there, that's a, let's say your account, right? There are two things. You have a bank account, okay, and you have banks. So let's say you have a bank account in State Bank, right? And you have an account. So there are two kind of hacking is possible. One is State Bank server is hacked, okay? So they can do anything, manipulate. One is your account is hacked. That means somebody somehow got your username and password and logged in. Whatever is happening, hacking you, you are hearing, that's your account is being hacked, not the server. The server cannot be hacked. And that's what I will tell you why blockchain network cannot be hacked, because it's a distributed database. Let's say, UPI model, let's say, let's say UPI has a distributed database, right? So UPI has a database, same database. State Bank also has the same copy of the database. Axis Bank also has the same copy. There are so many entities has all the same copy of the database. So when you do a transaction, somebody hacks UPI database and they say that, okay, I want to transfer, I don't have the money, I still wanted to change the value and say I have 20 lakhs and transfer, because the database is distributed, everybody has the same value. So if everyone in the network, everybody has to say yes, he has the value. So to hack it, you have to hack everyone. So that's why there is a something concept called 51% attack, but that's also going away. 51% attack also has a problem, which Bitcoin network has. So blockchain is more than that. So now you can have something called trusted peers. So maybe I think you might know something seems like. So that's a very good question, and I'm expecting similar questions. So let's understand what the blockchain data structure is. Okay, so that is where I guess you all should focus on, because you all know data structure is. I hope you all know, already have been studying the tree, linked list, stack, queues, all these things, and you all know relational databases. So blockchain is a non-relational database. Okay? It's not a relational model, and it's basically, if I consider one instance, like one database, so basically it's a set of blocks. So what happens is that in a typical bank, right, when you have some money in your account, so what happens in a database, in a table, you have your account number and you have and a credit and debit column. So you have basically, okay, every day or every transaction wise, how much money came in, how much money went out. And then all the sum is basically your balance, plus and minus, right? So your money, so in a bank, in a relational database, your account, your credit and debit balances are tied together. And if somebody hacks it, they can change the value and they can, so that's why there is insecurity. But in the blockchain world, it's a little different. There is a concept called UTXO, which is called unspent transactions. So basically, if you correlate the same thing, let's say you first received 1,000 rupees in your account, and then you spent 100 rupees for a shopping, and 200 rupees again for another shopping, and then you received another 1,000 rupees for next month's salary, let's say. So you have a balance together, right? But in the blockchain world, what happens is that in a blockchain database, there is no such thing like account-wise. It's think of it as a set. Every set has a UTXO. So every UTXO is basically saying, let's say when you receive 1,000 rupees as a salary, it will basically create an UTXO of 1,000, and it will be locked. When I say locked, cryptographically, using your account number. So your account, so it use all blockchain use a public key cryptography. So that means you need a public key which will be used to lock the UTXO, and you need a private key to unlock it, to get it. So basically not exactly private, you need a digital signature which should be generated using your private key. Because digital signature will be shared also. So in a blockchain, you can think there are two parts. One thing is a set of UTXO, which is basically all the transactions in a. It's a flat set. It's a list of collection of all UTXOs. And how do you know out of all UTXOs who owns what? And that's why you need to look up based on your public key and say, okay, this is my public key, and in this set, I see this public key, this UTXO is attached to this public key, and no one can claim it until you have the digital signature. That's one part of it. The second part, that's not blockchain. That's called UTXO set. The second part you see in the blockchain is basically primarily used for tracing, transaction tracing. So the first part is used for settlement, consensus. Second part is basically your blockchain, which is used for traceability. So blockchain use, I think I haven't read in my curriculum, but later on I read that it's called Markle tree. It's like a binary tree. In a binary search tree, a parent has two child, right? What happens is that, and then every child has a reference to its parent, like a linked list. You have two pointers, left and right pointers. So it's a similar thing. The only difference is that the data blocks are all under the hood, and basically it's a hash pointer. And now, how many of you understand what hash is? Anyone understand what hash is? But let me just quickly tell. Hash is basically like this, right? Let's say simple term. You are watching a movie, and you are telling your friend, "Hey, I couldn't recall this movie name, but there were certain scenes. There was a hero who is doing this. You don't explain the entire movie. You explain some pieces, and your friend, okay, this is that movie." So what does it mean is, hash is that a very long information you have, right? So, but to tell someone, instead of sending the entire huge bytes of information, you just send some pieces of pointer chunks, which comprise the hash, and that tells all the people, okay, this hash is related to this. The hash is irreversible. That means if you have a hash, you won't be able to get the actual information, but this hash is generated for that. If you say certain scenes, you can tell, okay, these scenes are from the movie, the original movie, but you cannot create the movie from the scene because it's smaller. So hash is a very small, fixed size string or characters for a long string. In Bitcoin or in blockchain, generally they use a 256-bit SHA-256 hash. That's a cryptographic standard they use for representing an information. So if you see in this diagram, right, what happens, the way, let's say a day there are 10 transactions is happening. So there is a certain limit that a particular block can have certain number or certain size of transactions. Let's say 10. So a marker tree will be formed for all those transactions, and the root is basically, there's a root hash for that tree. I mean, you can read more about marker tree. So that root hash is basically the hash of the block. The block can be identified by the root hash, and then so that block is formed. The block is formed. The block has a set of transactions. Every transaction has a set of UTXO, which is shown above. That's a block. And then a next set of transactions happening. So those are again, they will form another block, and that block will be, so understand, this is very important to understand. All the hashes, basically the root hash is combination of all the hashes of the information transaction you have. If you change anything about the transactions, the hash will change. So why this block, and that's how the whole chains are connected. So if you go back to the history, you cannot change anything. You cannot change any information of it. That's the power of the blockchain, because this data, even if it is hacked, you have to change all the blocks going forward. It's very difficult to hack it and change it. That's why it's called immutable. So that's a few pointers I've given. Like, blockchain is a distributed database managed by a decentralized network of nodes, where every participant in the network potentially can have the entire copy of the database. So that's what I say. Everyone has the database. So if everyone has the database, you cannot hack it. Second is that the data structure of the blockchain is hash linked list, where every block can hold a certain number of transactions in a Merkle tree, and every block also has a hash pointer to the previous block. And blockchain is immutable, and UTXO and the blockchain. So this is a basic structure. So for the time being, think of it like, it's not relational. It's like another kind of database which is immutable and cannot be hacked. So any question on this, especially the data structure guys? Yeah. Sorry, can you be louder a little bit?
এটা দিদা আরে ওয়্যারলেস না না এইটা যাবে না ওয়্যারলেস নেই ওয়্যারলেস আছে আছে জানি না আছে হয়তো ভেতরে আছে
Whether blockchain works at a time of recession or inflation, what's the strategy behind that? If a person wants to get their money back from the bank, and if the bank is not answerable, what's the strategy?
Right, very good question. So I'll answer that. So first of all, as I said, right, the blockchain is a different implementation. If you're implementing blockchain for money or currency like Bitcoin, so it's deflationary, the way it says. So there is though I don't want to focus on Bitcoin because it's not a legal tender in India. So my focus is primarily on the blockchain. But if, let's say, one day Indian government wants the rupee in blockchain, right? Rupee as a cryptocurrency, then what will happen is that today the way government kills rupee is by printing. So basically, you need to understand how inflation works, right? Do you understand how inflation works, right? Let's say you.
How blockchain works at time of inflation?
No, that's what I'm saying. Before you talk about the blockchain, you have to understand how inflation works, right? In economy, let's say Indian government said, in economy I have 10,000 crores of money, right? So they have to say there is a corresponding 10,000 crores of assets government has. That's why that gives them the ability to issue money, right? If the money they are issuing, that's a debt. That means they are lending that money. They are saying to the people of the India, hey, I owe you that money. Your job enables me, the work you do, right? You produce something valuable. But what government does, whenever they need something, they print more money, right? They print more money, so the overall value is same. So that creates inflation. But in blockchain or Bitcoin world, they said, okay, you cannot have more than 21 million Bitcoins. So when you say that I cannot print more than money, so it's basically deflationary. That means you will never have inflation. But that's not the right solution also. So to answer your question simply, there cannot be inflation in Bitcoin or blockchain. There cannot be, because the process is transparent. You are saying, you are already saying you cannot have more than this much currency. in your circulation. So you don't have ability to print more money. Today, I mean, this is not technical question, rather it's a little bit economical question that, how inflation works. And to beat inflation, because today people manipulate, right, this inflation data, government, whenever they want, they can print money. And when they print money, they're basically reducing the value of the people's money, right? But in blockchain, it's so transparent, you cannot print money. Because to print money, you have to follow certain rules. Because the rules are validated by machine, not by the human. So today, when you need to print money, same rules are there on the book. But now, people, it's validated by people, right? So that's why. So does that answer your question? Okay, so now, I come to the so the main things, okay, where am I more interested?
Sir,
Yeah.
first of all, thank you for coming here and giving this lecture. I have some questions. The first of all is, as you are saying that the database is immutable and it is distributed in nature. So there will come some time when the size of the database will be so huge that the system will be not able to operate.
Correct.
So it is from the implementation point of view. And the second point is, as we are saying that we are removing the problem of trust, we are putting a second party, a third party in between the customer and the buyer and the seller. So the trust is one issue. That's why third party gateway or whatever it is required. So here, as it is totally distributed, so we don't need any trusted authority or something like that. But in that case, as it is a distributed network, so some sort of majority protocol should be used, I think.
That's what. So two questions I think you asked. One is the issue with the size of the database.
And third question is there. So if majority protocol is used, then how the node selection will be there?
Okay.
So
Three questions.
Is it a structured peer-to-peer network or unstructured? Probably unstructured.
Yeah, so that's what I'll answer all three questions. So the first question is, hey, I think these are very valid questions. So yeah, so I think this is a very valid question. So because blockchain is, it's capturing every block, right, in a chain. So when the number of transactions will grow huge, the database size is bound to grow huge. At present, the Bitcoin database size is around 400 GB. Okay. So it's bound to happen, right? So what is the solution? So so there are a couple of, so it depends on the kind of implementation you are doing. So if you see this, so there are two. So the understanding a lot of people have initially that why do you? So there are two aspects of blockchain, right? The most important is the consensus. You said, right, when you want to do a validation whether the transaction is legitimate or not, that time you don't need the blockchain. This is what people initially I also didn't understand. You don't need the blockchain to validate whether a transaction, the entire blockchain. You don't scan from the top.
So here we are following optimistic approach.
Yeah, so that's why the UTXO comes. UTXO said, you have a set of pool of transactions, you have set of pool of assets basically. That can be a cryptocurrency or can be any assets. And that assets is locked by the private key of someone who owns it. So when you want to do the transaction, like that means you want to transfer that asset from one party to another, to validate whether it is legitimate, it just needs to go to that pool and find out where is the UTXO is, and the party who wants to do that has it provided the digital signature or not. So blockchain is needed for transaction traceability, not for validation. So transaction traceability is like open. So my case is, as we go over right now, we still have no problem to meet up like 500 GB kind of storage. But as we grow, I guess there will be some, certain point, right? Like in banks, what happens is when we go there, bank says you cannot get a transaction statement more than 2 years back. I can only retrieve. So what they do is they archive, right? And there is a regulation for banks that I will only retain only last 10 years data. I cannot retain. So right now, I feel that when this will be unmanageable, because this data is only for traceability, not for consensus, not for validation. So maybe some point they will archive, and that's a still open question how the people will manage. But I feel it will be similar to banks. They will archive and they will just show, okay, I cannot go back because traceability, you can only trace up to certain nodes from the bottom. You cannot trace all the things. So certain blocks, I can say, So only current block to last 20 million blocks I can go back. Before that I don't have it. Yes.
Sir, does it increase like Hadoop like principle that becomes distributed on different servers?
So Hadoop, I have not worked extensively on Hadoop, but what I can tell you, the Hadoop concept is different. That's the map reduce, right? So a very large problem, you are dividing into small problems, and you are solving those small problems in a separately and aggregating, and that's how it's a divide and conquer fashion. But blockchain is not divide and conquer; it's a distributed database. So Hadoop is different. Here we don't have issue in terms of CPU or memory processing. Hadoop is for big data, right? So you cannot process the huge data by one CPU or one shot. So you are distributing it in multiple machines or multiple cluster of machines, and then you are doing it. So I think Hadoop is a different thing.
So this means we can generate transaction history like that, and we can go back like since we have many statements from bank and
Yeah, actually you're right. So that's another thing, that's another possibility that right now we are putting the entire blockchain database thinking that it's distributed, but every node has a one copy. So in future, maybe every node wants to keep that as a separate, another portion. I mean, that always they can do. They can retain certain blocks on the rest of the day. They can go into hard disks or archive data or somewhere else. Yeah, so that's one question. So second question, I think you asked the trusting, right? So that's where our thing, the spiral, which is inspired by two other networking models. So I think in blockchain world there is two things. One is proof of work. So what happens is when how the new coins get created, something called mining. Okay, so that's a very wasteful of electricity. So what happens is that every node in the network, someone is spinning up the nodes, right? Node means a server, a software you are installing in your machine, and you are giving a huge CPU disk or this thing. So you are working as a node, and when you create a block, you get an incentive. That's called rewards. And how do you get an incentive? That you solve the cryptographic puzzle. Basically, in Bitcoin world, they said, you have to come up with a number which has certain number of leading zeros, and that number should be will be the hash of your public key. Okay, so so what happens is that that's a very, I think that's a separate topic. I don't want to go into that topic because that wastes a lot of crypto electricity power. So what happens is that instead of mining to reach to a consensus, people are saying that we will use something called proof of stake model. And in proof of stake, there's something called trusted peers. So let's say today I have 20 nodes, right? So let's think about same thing as the internet, right? I have an ISP. When I route the I receive an information, I think that it is a server which I do not have a direct connectivity. I will route to the next server which I trust. Same thing is going to happen here. There will be a trusted peers. So I will only say this transaction is legitimate if it is part of the trusted peers. So the trusted peers, and how a node can be trusted peers, that process is not automated. So there is something that the banks are using called Stellar and Ripple. These are the protocols, and similarly we are trying to do the same thing to Spiral. Is that we will have a registry, Spiral registry, but trusted peers, the nodes, when they spin up, they will have to register there. A register means that process will be manual. So, and that might need some KYC information. Let's take an example of university results, right? Let's say all the universities. So let's say university, the UIT built a software, a blockchain, and they say, okay, they start with university, just the University of Burdwan, and they say, okay, all other universities are free to join us, right? So let's say Jadavpur University, Sipur, all this university, okay, has shown interest and they joined, they opened up the node, and you put them on your trusted peers. But let's say a private university, someone you don't know came up and opened up the node, and when any certificate will be issued by them, if it comes to you, you won't say, yeah, valid, because you don't trust them. The trusted peers, they have to be with you, separately, so that is, but still, here's the thing, right? The beauty of this is that the trust might not needed everywhere. Let's say the blockchain network you created, the same thing someone is using in the China. They copied your thing, right? They say, okay, I don't need to trust. I don't need a trust from the Indian university. I will be only certain Chinese universities trusted. That's fine. So when you go to some company, they can select, okay, where from they expect the trust. So that gives the power of whom you trust. So, the node, it has a lot of flexibility through this registry model, that who should trust whom. You can build up your own trust. Like a forceful monopoly, you can build your own trust. So at the core, you have a spiral code or kind of a blockchain code which does the management of the blockchain. That means adding, updating the UTXO, updating the blockchain, and you have an API. So today, I will take an example of Paytm, right? Most of you use Paytm. So Paytm is